So far, we have worked with the simulator to simulate two underwater nodes to form a network using acoustic links. While these nodes are very similar to what acoustic modems and in real life, they are not exactly the same. So if you have two or more UnetStack enabled acoustic modems, you can use them to set up a simple two-node or multi-node network. All you have to do is just take them, connect them, put it in a water body like a small bucket if that's what you have, or even on a large tank or a lake. Once they are powered on, you can just connect to them using your web browser and by typing their IP address in there. And that will give you a web shell that looks almost exactly the same as the simulated nodes that we have just seen. Assuming you have the modem in a bucket, you will need a very low transmit power. On one of the modems, let's set the transmit power to -50 dB and let's try transmitting to the other node. All you have to do is type PLVL -50. And then if you type PLVL, it will show that the power level has been set to -50 dB. You can now proceed with transmission and reception between the two modems just the way you did it using the simulator. Any examples that are in this video or in the subsequent videos or in Unet handbook will work exactly the same as in a modem or if you run on a simulated network. Now that we have seen how to transmit and receive information or data between two simulated nodes or even real acoustic modems, let's take a look at what are some of the other things that we can do with UnetStack. If you have a UnetStack compatible acoustic modem that supports baseband service, you can use them to transmit and record arbitrary acoustic signals. Even without access to modems, you can try this out using the UnetAudio SDOAM, that stands for Software Defined Open Architecture Modem, which is a fully functional modem that uses your computer's sound card for transmission and reception. To run UnetAudio, you will need port audio installed in your system. To start UnetAudio, open a terminal window in the simulator's root folder, type bin/unet -audio, and that will open a browser window that will give you a web shell towards the UnetAudio. You can do the exact same thing that we did earlier with simulated nodes by typing tel 0, hello and press enter. And that's the transmission that you will hear. Now that we have done simple transmission using UnetAudio, let's try by sending a simple 10 kHz tonal signal by typing bbtx CW 10,000, 0.5. The function CW generates a signal based on the specified frequency and duration. You can find the carrier frequency and baseband sampling rate of the modem by typing phi.baseband rate or phi.carrier frequency. In the SDOAM, because it's running in my laptop, the carrier frequency is set to 12 kHz. So the baseband signal is represented as a floating point array with alternate real and imaginary components in Java or Groovy. Now that you have done arbitrary waveform transmission, you can also try an arbitrary waveform reception by typing bb_rec and then give the number of samples to record, and that will record 1 second worth of data. We can actually check first 32 samples of the signals by typing ntf.signal 0.32, and that will print out the first 32 samples of the signal. Just to recap, so we have started by simulating two nodes and sending and receiving data between them. Then we have used the Unet socket APIs to transmit and receive information between the two nodes again. And then we moved on to UnetAudio, that is an SDOAM. We showed how to transmit and receive signals and data. While we used the bbtx and bb_rec commands to do the transmission and reception of arbitrary signals, we can also use TX baseband signal request and record baseband signal request to do the same. Let me show you how. And that does it. Also, we can do the same for recording of a baseband signal, and that will record 12,000 baseband samples. So that's it for this video. We will continue this in the next video where we will cover the next chapter in the Unet handbook, that is the UnetStack basics. See you.